Hey everybody, this is Jacob from Blind Spectrum, and today we are going to be covering binary. For those of you who don't know what binary is, it is a counting / number system used by computers, computers for the most part. There's other uses for it, I'm not going to get into that, but anyway, computers see everything as either a 0 or a 1. As most of you probably know from movies and such, using binary to make computers sound different, or whatever they use them for. But the whole 0, 0, 1, 0, 1, 0, 0, 1 thing that you always hear in movies. But anyway, first I'm going to cover decimal, which is our counting system, and then I'll get into binary and cover the differences. So decimal, which deci means 10, is our counting system, and it works on a 10 system. So we have 10 digits to choose from written out here as 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then after we reach 9, we move over to the next placeholder, which would then become a 1, and then the first placeholder, which used to be 9, is now a 0. Now, this is all fairly familiar to us, and we're all used to counting in our own number system. So it all makes sense when we go from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 to 10. It makes perfect sense to us to see the 9 become a 0 and add a 1 in front of it. And then we get to 19, and then the 1 becomes a 2, becoming 20. And then all the way up to 29, and eventually 30, 40, 50, 60, 70, 80, 90. And once we get to 99, then they both become a 0, and then we add an extra 1 at the front, making it 100. That all makes perfect sense to us until we try to translate those numbers into a different counting method, which is one of them. Well, there's a lot of counting systems for many different cultures in the world, but the one that is probably most common for people to learn as a secondary counting system is binary, mostly because all computers across the world read everything in binary. So binary, bi, means 2. So it works on a 2-digit system. So we have a 0 and a 1. In binary, you will only ever see a 0 and a 1. You'll never see a 2 or a 5 or a 7. Nothing like that. It'll always be a 0 or a 1. So that means that we go 0, which is still 0 to us, 1, which is also still 1, but then after that, we go 1, 0. Now, our instinct is going to be to read that as 10, but when you're writing binary, 1, 0 means 2. And so that once we reach 1, we automatically move to the next placeholder. So the 1 becomes a 0, and then you add an extra 1 in front of it. So 1, 0 in binary reads 2, not 10. And so we move over and we make that 1 a 0, a 1, reading 1, 1, which is normally 11, but it actually reads 3 in binary. And then here we have 1, 0, 0, which is the next placeholder, which we would normally read as 100 in decimal. But after we reach 11, since we only have the 2 digits to work from, or sorry, not 11, 1, 1, see, it's still hard for me even to not read that as 11. But anyway, after we reach 1, 1, which is 3, we move automatically to the next placeholder because we don't have any other digits to work from, which becomes 1, 0, 0, which again reads as 100 to us with our normal decimal eyes, but it's really 4 in binary. And then so 1, 0, 1 is actually 5. 1, 1, 0 is 6, and 1, 1, 1 is 7. Now this is all fairly confusing. It was for me too the first time. I felt like my brain had melted when I was trying to learn it. This is not an easy thing to get accustomed to. We always want to read 100 as 100, or 110 as 110. Now, a trick that I learned to help me grasp the concept of binary was to write out a chart, like you see here. So 128, 64, 32, 16, 8, 4, 2, and 1. These are pretty much the only placeholders we will be working with as IT professionals. That's because what we're working with most of the time are IP addresses. And IP addresses are all written in 4 groups, well, at least IPv4 addresses are written in 4 groups of octets, or 8 binary digits. So in total, there's 32 binary digits written out for an IPv4 address. Now, this is important to know because every time we're looking at an IP address, it'll always have 4 numbers broken up by dots. So, for example, we'll see like 192.168.0.1. This is only written out this way to be human readable, so it's always written in decimal because that's what we understand. But the computer is actually reading this in binary and then translating it for us. So each one of these 4 numbers is actually an octet in binary, made up of digits corresponding to the 8 numbers you see below it. So we as IT professionals need to be able to translate both binary into decimal and decimal into binary. And this is, well, not exactly easy at first. It takes a lot of work to be able to do it without writing it down. So let's take let's start by going from binary to decimal, which is, in my opinion, the simpler ways of the two. So let's take a binary number, 10101010, right? Yeah, okay. Sorry, I'm going to make sure I had 8 digits there. So this chart I have written out here is something that I use to help myself learn binary, because trying to read it as we normally do numbers can be somewhat complicated because we're trying to not see what we normally see and see it in a different way. But this chart helps break it down into a more readable format, a more calculable format. So what you do is there's 8 numbers there and there's 8 placeholders, so you just line them up like 1 0 1 0 1 0 1 0. So now wherever there is a 1, you add in the corresponding placeholder. So since we have a 1 in the 128 position, it's 128 plus, there's a 0 in the 64, so we don't add that. So I'm going to put a 0 for now, plus, and there's a 1 in the 32, so plus 32, plus, again, a 0 in the 16, a 1 in the 8, a 0 in the 4, a 1 in the 2, and a 0 in the 1 place. So 10 10 10 10 will essentially, to translate it to decimal, we would do 128 plus 32 plus 8 plus 2, which will equal, give me a second to do that, 170. Right? Yeah, okay. So 10101010 in binary translates to 170 in decimal. So that's fairly confusing at first, I know. It's going to take a long time, a lot of practice to be able to get that right. I know it took me at least a few weeks to get the handle on this. Not going straight, obviously, but I was working on other things. But just, it takes practice. This isn't going to be something that you're just going to be able to look at and automatically understand. And this way, going from binary to decimal, is the simpler of the two, like I said, at least to me, because all you have to do is break the numbers apart and add in the corresponding placeholder. Fairly simple, fairly straightforward. What's a little bit less straightforward is going the reverse. So let's just take the same number. Well, let's not take the same number. Let's do 149. We're going to break that into binary. So let's write out the placeholder again. Okay. So here we've written out our placeholders again, and we have our decimal number. So in order to make a decimal number into a binary number, oh right, sorry, I forgot to mention that for an octet, again what we're working with is an IPv4 address, the decimal numbers you will be working with will range from 0 to 255, never above or below. You can't have any negative numbers when you're working with an IPv4 address. So if these are all ones, you would have 255, and that's the highest we can go for an IPv4 address. So it's pretty much where you'll be working with when you're doing binary for computers, because IPv4 addressing is where most of the binary we're learning is going to be used. So if you're trying to translate anything above that, you're going to have to apply what I'm teaching you here to go beyond the 8 placeholders. Just multiplying by 2 every time you go over a placeholder to the left. So in order to translate this 149 into a binary number, we have to go through the placeholders left to right, subtracting each one as we go, and if we can subtract it, we put a 1 there. And if we can't, we put a 0. And every time we put a 1, we subtract that number from the total. So start with 149, let's start at 128, put a 1 there, because 149 minus 128 nets us a positive number. If it had netted us a negative number, we wouldn't, but we put a 0 there, not a 1. So 149 minus 128 equals 21. So now we move on to 64. Well, 21 minus 64 would give us a negative number. So we put a 0 there, and we don't subtract anything. Move on to 32. Well, that also gives us a negative number. So we put a 0. 16, on the other hand, would net us a positive number. So we put a 1. So 21 minus 16 equals 5. So, and each time you subtract, you keep the number, so that when you keep going on, you're always working with the number that you just subtracted. So 149 minus 128 was 21. So then we used 21 as the number as we kept working down the list until we found one that worked. And so then now that we've subtracted the 16 from the 21, we have 5. Well, 5 minus 8 is a negative number, so we can't do that. So, but now 5 minus 4 is possible. 5 minus 4 equals 1. So now we have only 1 left. Well, 1 minus 2 is negative, obviously. So, not there, but 1 minus 1, I'm hoping you guys can figure that out, is 0. So, this, which I'll write out here, 1, 0, 0, 1, 0, 1, 0, or, oops, 1. So, this 1, 0, 0, 1, 0, 1, 0, 1 is the binary translation of 149 in decimal. So, it's slightly trickier because you have to keep track of your math a bit more as you're going through it. And especially trying to do it naturally without having to write it down is a lot more difficult. Again, use these placeholders written out like this if you can. I cannot express how much it assisted me when I was learning binary. So just keep going at it. If you don't get it right away, just consult this video or these charts again. Copy these down if you want to, because it's going to take time. You're not going to get this right away. Like I said earlier, it practically melted my brain when I was trying to learn this. It is not a simple thing to be able to switch your brain from reading numbers a certain way to reading them a different way. It's still hard for me when I see 100, 10101 to not read that as 10,010,101. That's what it looks like, a decimal number to me still. So it's, and I have to really work my brain to switch to seeing that as a binary digit. So it's going to take time and effort to be able to switch your brain into seeing things this way. But it's necessary that you do, especially if you're going to be an IT professional. You're going to be able to need to understand this. And so I really hope that this helps you guys out. As always, if you like the video, like, comment, subscribe, hit the little notification bell at the bottom of the video. Be sure to check out our other channel called SpectroCast, where Blind Spectrum is more relaxed, playing mostly tabletop games, things of that nature. So you guys can see us in a more relaxed and fun manner. I hope you guys have a wonderful rest of your day.